FDP on blooming research areas under IoT, a 360-degree view. Today, for session 11, I would like to introduce our distinguished resource person, Mr. Rajesh Thakare. He is co-founder and CEO of Electrosoft System. He has done his MS Electronics from North Maharashtra University, Jalgaon. He is a result-driven embedded developer with 10 plus years of experience in designing and developing embedded software solutions for various industries. He has expertise in developing firmware for microcontroller and microprocessor based system. From last 10 years, he is working for providing training towards industry, student, college staff, etc. Along with this, he has started development of various products like vending machine, CNC machine, solar panel cleaning machine, and many more. Now, I hand over this session to Rajesh sir. Welcome you, sir. Again, over to you now. Thank you so much.
Hello, I'm audible to everyone?
Yes,
Yes,
sir.
sir. Clearly,
Yes, sir,
sir.
you're audible.
Okay, sorry for starting this late session. We have some arrangement. So right now we are ready for the session. Okay, today's our session is about fourth day, and our session is based on Arduino programming and IoT and cloud applications. Am I audible?
Yes, sir.
Okay, okay. Welcome to all. And then without taking more time, we are just moving towards Arduino interfacing. So first of all, we have to understand what is Arduino. So I hope all are know about the Arduino, what the Arduino it means. So we can go with just Arduino diagram. So right, we have one Arduino board. Okay. So this is what my Arduino board is. You this we have Arduino board. So Arduino board based on Atmega 328. Arduino comes with the very compact module and very simplified module.
Sir, sorry to interrupt you, sir. Sir, can you please rotate your camera because it is coming in the landslide.
Okay. I can off the light. Okay. Is it okay?
Please rotate it once. Your this I think PC ka camera. I'm talking about PC camera.
It's not my PC camera. I'm using mobile camera.
Okay.
Because we have to show practicals also.
Yeah, that I understood, but it's not proper actually.
Okay, it is not visible.
It's visible, but it is coming in a portrait manner. If you'll do it in a landscape way, no, so it will be more clear.
And landscape manner use kara, sir, please.
Now, in this way only, sir. Little more towards the laptop.
Okay.
Perfect, sir, perfect.
Okay.
Yes.
Okay, I thought I can make it light on.
Yes, sir. Now it is clearly visible, sir.
Okay. Is it okay now?
Yes, sir. Yes.
Okay. Okay, we have Arduino board. So it's very simplified board. The application of this board to make a simplification of 8051 AVR PIC controllers. We use many of controllers, but it is very simple controller they have designed and they have worked on its bootloader. So what is Arduino? What is Arduino controller and what is 8051? We know that we teach most of the time 8051 to the students, but we know also that all students are not able to interface 8051 interfacing. So that's why some researchers have constructed Arduino board with Arduino Atmega 328 controller board. So what is the special in this board? In this board, we added a bootloader file. It is as simple. We have mobile and we have different kind of mobiles like Samsung, Oppo, Vivo. But in that mobile, we use Android OS. The same as Arduino use their bootloader before applying any applications. We use OS. Same in the hardware. Before creating any applications, we are using one bootloader. Bootloader makes simplification between the software, that means IDEs, and the hardware interface. So it is the first board which comes with that simplification, which anyone can start with the electronics boards. Like any mechanical students, any computer students can go very easily. So that's why Arduino is very famous. And second thing is it's open source. So you can use that hardware and you can create your own products. Already we have vending machines. We have constructed a vending machine over the Arduino only. So it's very easy. So that's why we have to start with this board to understand the different scenario of IoT, how we can go with the IoT. So first of all, I can go with the Arduino, let's say Arduino website. So we will get more clear about the views, what the Arduino gives us. So this is what the Arduino website, arduino.cc. I thought everyone is visible for it. Okay. So you can go on a just software site and IDE first. There are 2 or 3 IDEs. They comes with now PLC also. So you can go for Arduino IDE first and go for download. And here is the your ID. Here are some options like download options, and if any you have Linux systems are again here files and Mac OS like. So we can go for Windows and just go download for it, and it starts to get download. Okay, it is that simple, easy. Everyone knows about that. Once you open the software, you will come with like this window. Okay. Every corner of window is visible for everyone. Please give me reply because I am not viewing that. Okay. Is it okay, sir? Hello.
Yes, sir.
Okay. I'm asking about the lines. Are you these words are readable or not readable so that you can understand the code?
It is able, sir.
Okay. So that means you can see the words. Okay. I can take it more clear. Okay. Okay. It is very simple board. So it start with the simple IDE also. We have a number of 4 or 3 pins here. We know that if you use 8051, so 8051 has a little bit more complex. Like we have to construct a key and key. We have to manage one project, and number of steps are there to select the microcontrollers, then crystals, and number of settings. And after that, you can construct your project for writing a code. Here, its scenario is very simple. You just have to open the screen and you got the sketch page here and you can start your coding. So before that, we have to set 1 or 2 things that's called tools. Tools, and you can set just the board, whatever board you are using. Like I'm using Arduino, so I'm setting that board. It's a essential setting, and we have to just set this one. And second one is what port. If we are connecting Arduino board with your laptop, so you will get that COM port. Like right now, we don't have this Arduino board connected with the laptop. I'm going to connect the Arduino board with my PC. So it comes with some pin board. Like I'm updating it. Now you can see it. New COM port has come and COM30 with Arduino only. So it is that simple. You can select this board to upload your code. So these two settings are very important. Onwards, you can start your coding. So if you know about the basics coding like C programming, all know about. So we can start with the simple C coding, INT, which is data type, and then LED we want to make on LED. So LED 1, and on we can use on 12 number pin or 13 number pin. On 13 number pin, there is onboard LED. Okay, so we can use 12 number or 13 number. Okay, 13 number is onboard LED. And second one, here is two sections we have to understand very importantly. One is setup and second is loop. In a common C program, we use only main function. Within that main function, we write our all code. But in the Arduino, in the 8051, we use two sessions. Like within the main code, we use again while one to make difference between the setup and execution code. What it means. Once you start your mobile, uh, on window is something different and rest window, mobile operation window is something different. So there is initial routing where we call the initialization of all input and output devices, which is at least one time. After initializing all devices, which is input and output devices, the initialization has completed. After that, we have to just execute the whatever the application is. So that's why Arduino developers has created two sections. First is what setup and second is what loop. So what the purpose of setup is to write just the direction of pins and do whatever you want at least one to execute in the program. At least once you have to execute in the program. So we are using LED as an output device. So we can write here. So pin mode, it's pin mode. So we are using LED 1, then it's on a 13. So we have to make it LED out. So it's very common, simple. If you know about this, you can go with the simple library code like examples. You can go on examples and examples. There is some basics codes are available. If you want to try that without writing any code, you can go like that simple code basics and play. It is a first program that you can go with the Arduino board. Okay, example basics and play. But I'm going to write it from the basics, so we will get more clear. So delay. Here we are using pin mode LED 1 output. That means we are defining that we are using this pin as an output. If you want to use that pin input, you can write here input. Okay. So pin mode is defined as once in the code. After that, we are moving toward the session we called it loop. Okay. In the loop, we have to write code, which is we have to execute in infinity time. So that where we are making LED on and off. So we have to write digital write digital write, then LED 1, then it's high. So it's making high. That means LED will get glow. Okay. And delay of 1 second. After that, we can make it copy and paste to for making delay in LED off. Okay. Make LED off. So right now it's very small code and very basic code. Maybe most of the who are introduced about the board, they can have LED on off. Okay. So we just have to compile our code. So you can click here, save your code. Okay, and you can compile it. Compilation is moving here. So compilation is done. Compilation is done and we have to upload the code. So Make sure that our board is connected, port is selected, and then you can upload button. Press upload button. It's second button. You can press it and make the code upload. So once uploading is done, your LED on a 13 number, it is going to get on and off. Okay, we are viewing that small LED which is making on and off. You can change the delay. It's so simple that we can make the change in delay and make LED change with the time. We are moving again forward for temperature on off on IoT application. So it is just simple. Those who don't know about the Arduino, that's why I'm showing it. So we can see that on time is changed and off time is same as it is. Okay. Next, this is what the basics example that we have done. But now we have to go towards IoT application. So that's why we have to introduce Wi-Fi module, which is ESP8266 Wi-Fi module. It's commonly like it comes with the cake pin. It's ESP826601 module. I can show it on left. ESP8266 with one pin out. Then go with this is what the simple ESP826601 kind of module. It's very initial module. In that module, we have to use 8 pins, where the 4 pins are important: RX, TX, and VCC, and ground. These 4 pins we have to interface with the Arduino board. So this module gets power supply of 3.3 volt. It is very important that we cannot change the power supply. If you down the power supply, it is not going to connect with your Wi-Fi network. And if you are connecting with the Arduino board, sometimes Arduino board cannot provide essential power supply to the board. So you can design with LM317. So right now we are trying with the Arduino board. Okay. So for this kind of interfacing, we need some libraries called simple like okay, I can show it. Simple Wi-Fi, which can gives you multiple views like HTTP server connections and basic hello world on basic network connection. So this is what the simple file you can use for the hello world, where you can create web page on your mobile and you can access it. So we will go for the advanced one, which is a remote XY. So for the remote XY, we have to go to create one account on a remote XY. So this is what my basic code. You can go for new project and create window. So same LED on off we can do with same LED on off. We can go with a remote XY. So it's what properties. Okay, I think it's remote XY providing us opportunity to construct mobile app with your remote controlling and number of things you can do with the remote application. So we are connecting with the Wi-Fi access. So Wi-Fi access is selected and apply for it. Arduino board. Okay, there is another setting. And second is your Arduino board. So we have selected at Mega 328 board. So there are number others board. And the third one is your Wi-Fi module. So you can select Bluetooth also, but we are selecting this one. We have ESP8266 module 01. So we are selecting that and we are programming with the Arduino. So apply it. Okay. we have configurational settings. Onwards, you can write here, like I can show it how to construct mobile app with this. It is just a drag and drop application. You can start your coding with this. You can drag and drop here. You can take labels. You can put the label, and to change the label, we have here parameters like uh, IoT app. So we can make it, and then button is here. Okay, we have to set this button with the Arduino board where we are using that button on which pin. So and go with this. Here are the some settings where you can select the Arduino board pin, like 8 number. We can go for 8 number pins and get. Now we are just making LED on off through the remote XY using the Wi-Fi module. Okay, so my configuration and properties are set like ESP. Okay, we have to set SSIDs. So SSID, I am connecting with light, and my password is light1234. Okay, that is very essential. SSID and password setting and port. We can change the port, but if you want to use same port 6377, no problem. Okay. Here is most important is it's very easy to create a code because once you created this application, you can go with the just get source code. You can click on it. You will get the source code. Okay, for that source code, we have to install one library, which is remote.xy.h. If you want to access that library, here is the link. You can go with libraries. So it is showing on a page where you can download the library from the GitHub. So basically, we have installed this library. So I'm copying the code. Go on the same stage, previous program. I'm deleting it and putting new, and just adding comment again. Okay, I thought now code is inserted. Okay, what what kind of connections we have to understand? We're using this remote X1. See, we are using a Wi-Fi on a 2 or 3 number pin where the RX and TX is connected on our board. And second one is SSID and password. So SSID is live, and then password is live1234, and the port. These are the common settings we have used. And whatever the API we constructed on the this dashboard with this. Okay. We have constructed this kind of scene. So it is creating a simple link and thing here that to make it configured. And this is what the switch will make it on and off, defined in instruct, which is controlled by remote, and pin connection. So it is based on a 8 number pin setup, initialize pin as an output, and loop, where the button is getting on and out. So we have to make connections for this program. So we have Arduino board. Okay. So we are making connection with the board. 1 minute, I can manage some things. So can get very. Okay. Here we have Wi-Fi module. It has one resistor connected to mix pin pull up. These are 8 pins where RX and TX, and this is what VCC, and above is ground. Ground, and then we going to see, you can go with the wires. So wire has colored, like this black wire is of ground. This red wire we have connected is VCC, and the others are RX and TX. So I'm using onboard power supply, which is 3.3 volt, and the ground on board. Okay. And then RX and TX connected to board, which is 2 and 3 number pin, as we have seen in the program code. Okay. And there is LED, which is connected on 8 number pin, because we have made that LED based on 8 numbers. So I have breadboard. I am using LED to make it on. We have resistors. Okay. It is connected with some cables. Okay. LED is connected with the 8 pin. I have to connect ground. I need cable. Okay. I need one cable. Wait a minute. Hey, mail to mail. Mail to mail. Stability for a different pin. Hmm. Okay. I get it. Okay. I get it ground wire. So it is connected to here, and again to the ground. Okay. So my connection is completed. Here is my Bluetooth Wi-Fi module, and LED is connected. Arduino board is connected. Now I'm going to upload that code, whatever we have generated through remote XY. Okay. So same code I'm going to upload. So once we upload the code, we have to install one app, which is provided by, again, remote XY peoples. So Wi-Fi module is on. Our Wi-Fi module is on, and we have to make hotspot on to connect it with the hotspot module. Okay. Make sure the settings of hotspot module, like light 1234, as we have defined in the SSID and password in the remote XY session. So we have connected with this, and on the hotspot module, and make it device connectable. Go for Wi-Fi access point, and the Wi-Fi. Okay, it is getting some time for the connections. Due to its real-time application, it takes some time for the connections. So password is light 1234. Okay. Okay. The server of remote XY is not properly working. We are trying for this for a little bit. Otherwise, we will shift towards next scenario, which is ThinkSpeak, where we can monitor some sensors. Okay, it is giving some error. So without wasting our time, we will move for the monitoring of temperature sensor. So for that, we have to create one account on a ThinkSpeak. So based on that, for moving on ThinkSpeak, we have to construct one new channel where you can go for channel, put some name, IoT based, whatever monitoring or IoT based temperature monitoring, and again field. You can create one field. We have constructed one field which is temp. Okay. So it is based on a cloud application. So we can go for this new channel. Once you log in into ThinkSpeak, so you can go for the channel and new channel, create channel with some name and a number of fields, whatever you need, and go down and save the channel. So channel is created based on IoT temp monitoring, and here are some settings like private view, public view, channel settings, shares, and API keys. So here we have created one chart field. You can visible it for the temperature. Okay. It's very important to see API key. So once you press on API, you will get one API key. We have to write some data on API. So that's why we are copying this key and putting it into our code. So we have a simple code for ThinkSpeak. Go for it. Okay. Here are the some settings same as remote XY, like RX and TX connected on a 2 or 3 number pin, then light, like our SSID and password name light and light 1234. And here is the key that we have to put. Okay. This is what API key we have written here, which is mentioned in ThinkSpeak. Okay. We can copy it here and go down. Okay. We have to make temperature sensor. So in this setup, we have started serial communication to monitor whatever going in the controller, and we can see all results on our serial terminal. So we can know what the going on, whether connectivity is established or not. We are using one LED to indicate that Wi-Fi is connected and network is on. And this is what the simple thing to connect SSID and password. So these are some AT commands based on ESP8266. So we have to know about this command. If you know, there are some forums which can give you a simple code. Okay. So this is for loop session, and here we can write our code like generated get data where we have to write API key. So API key we have mentioned at the initial stage. At here, this is our API key. It is very personal because anybody can upload data on that API if you share with them. And the field is important. We are using first field for the temperature, so we can go for single field. In this code we are using two fields. Okay. This is what first field we have selected, and a temperature function, and then go for bottom code where we are using a temperature functions. Okay. So temperature is what we are using LM35 for the temperature measurement. It is like a transistor kind of device which can gives you temperature from minus 25 degrees Celsius to plus 125 degrees Celsius. Three pins are there: VCC, ground, and output. So the three pins are there. We have to connect with the Arduino board. So here is A0 terminal on the Arduino board. A0 terminal where we can give analog input. Analog input. A0 is mentioned here. So we can connect A0 for the temperature sensor, read the temperature. And here are some formulas where we can create voltage value to the degree Celsius value and upload it on a cell. So this is what the simple code we have constructed, and we have to go for our channel to visualize it. Okay, right now here is not any data available. So we will connect this board and upload our code. So we have to go for this. Tools, board is selected, and code, compile, save the code. Then uploadation of code is processing. Code is upload. Then we can go for the serial monitor. AT command is okay. Light, it is connecting to light terminal. So I'm going to connect my LM35 with the with the board. So there are some pin I have to connect. So here is the ThinkSpeak is okay. My Wi-Fi is connected with light and light 1234. Okay, it is done. And after that, it is sending some values on a ThinkSpeak. Okay, failure. It's going on. That means it is continuous process where it can goes for fail, it goes for high. Okay, I'm not connected yet my temperature sensor, but you can see one value is come on portal. Like whatever whatever the value is. Still, I have not connected my temperature sensor, so that's why these values are coming. Once I connect my temperature sensor, it will show the perfect value. Okay, wait a minute. male to female wire. I have to use male to female wire for it. So start is not my Dex. Thank you. The hardware code we have to go with the more setups. In the software session, it's quite easy to represent. In the hardware, it is quite difficult. Okay, now my temperature sensor is connected. I have connected my temperature sensor. So you can see it. This temperature sensor is connected with the A0 line. So we can get the value if those are correct. It's uploading on my channel. So we have to see whatever the values and values are. Values are all the time coming. So it is very simple use of ThinkSpeak where you can monitor your data. So it's all the time coming. Whenever it goes for fail, it is not sending data to the that cloud. Whenever it goes for okay, like there are number of times fail and some of the time it is get on. Okay, values are coming. Okay, here are the some values. So we have conclude the session where we have go with the LED on off remote XY due to some network failure. We are not connected with the remote XY where we cannot blink LED on off. But in the session of ThinkSpeak, we have connected with the one channel which is IoT based temperature monitoring, and we have created one channel where we use API key. Any server use their API keys to connect with the particular device. So it is very specific. So we are using this key in our code. So we have hard coded it here with the some settings, and obvious we can get that value based on the fields and temperature function, and whatever the calculation we are doing in the function, it is going to upload on that module. You can see it privately if you make your channel public, so you can go it for publicly use. Okay, this was the basic introduction of IoT and IoT cloud programming. It's not that easy. We can learn this all in a single session within time frame. So I hope you all are can understand what we have shown in this session. Hello. हाँ sir. Hello. Hello.
हेलो हाँ हाँ सर, हाँ
हाँ
सर,
sir.
प्लीज आस्क.
Okay. So we have done these two modules where remote XY is not connected due to server, but we have connected with the ThinkSpeaks and upload some values. So we have shown them. So if there are any questions, they can ask me. Hello.
Hello, participants, please ask your questions. Hello, sir. I want to ask one question.
Yes.
Yeah, yes, sir. DH. What?
Hello.
Hello, हाँ sir.
Sir.
Yes, sir. We want to know how to interface DHT sensor with Arduino to get clear results because it can
Okay.
sense two parameters at the same time, na? That's why.
Yes. Okay.
Hmm.
So for that DHT11, we have one library called DHT. Okay, I can show it. Examples. So DHT library sensors. So it is available on a GitHub. We can go for installation of this, like in the tools, then a sketch, then include library, manage, and in the manage folder, you will see that online basis DHT11. Okay, it will take time. You can open it on a side by side. Okay, this is DHT11 sensor, a library for Arduino. Go on a GitHub. Okay, here are the codes. We can download it. Okay. Other end, we have opened this. Okay. We already have downloaded the file. We just have to add into because we I have already added, so it will not get added, but I can show the procedure. File.
Yes, sir.
Okay. File and include the library. Add library zip. And in the download section, so we can see here DHT11 library 1.4. So you can add it and open it. So it will get add. If it is clear library, I will see it is not all. It is showing that already exists. If it is clear library, it will upload either if there are any error, it will show in the color. Okay, so we have already seen that DHT11 I have. So I can go with DHT11 and of test. Okay, so we have opened the code. Oh. So in the code, we see that it is connected with the 2 number pin. We can change it to whatever pins number they have put here, 5 number. You can change for 5 number. Most of the time we use 2 or 3 number pin for the RX and TX. So here I am committing the other code and opening DHT11. There are number of sensor DHT11, DHT22, DHT21. So they have made this code for 22. I am changing that setting and opening my DHT11. Okay, and go for bottom, and you can see it here. DHT. It is kind of a class DHT, and it is creating object with the DHT pin and DHT type. That means DHT pin connected to. We have changed it to 5. And DHT type, that means 22 or 11. We have changed these two settings, and that's why it is getting updated with the DHT. Once we have done this, then in the setup, it is DHT begin. So DHT will get on. DHT sensor will get on. It is quite smart sensor. Okay. In the loop section, they have created a DHT read humidity and read temperature. Two functions are there, which is returning value for H and T. H for humidity and T for temperature. So we can use these two variables for uploading on a ThinkSpeak for H and T. So you can upload your code to with connecting with some Wi-Fi model, like as we see our temperature on ThinkSpeak. So here is the code, simple code. We have to merge this code, these two code. Like first one is with ThinkSpeak, where we have settings like light and all and API keys, and we have to put this another code of DHT11. If we make correct combination of these two code, you can upload your DHT11 sensors value on a ThinkSpeak. Okay, sir?
Yes, sir. Yes, sir. Thank you very
Okay.
much, sir, for detailed insights. Sir, one
Okay.
more thing. Just like ThinkSpeak, can you please tell us another platforms which are available to analyze the data using IoT?
Okay, there are number of sites like Remote XY itself providing a cloud-based service. See, we can go for a Remote XY and we can go change for Wi-Fi to cloud. We can go for cloud also. So again, there are settings like cloud. Apply it, so it will change for it. So I can show it my tokens. So we have generated these two tokens. Same as in a ThinkSpeak, we construct this API token here for to API token to write our values. Same here, we have to create token, cloud token to represent the value. So Arduino, this is what my token. You can create new token. See, token. So I can write my project name like I want to create DHT11 based, so create and then go for down. And this is what my next token. I can copy this token and add into my account. See, so if I put here two measurements, one is for temperature, another is for humidity. And here are some token settings. See, here are some token settings. So I can change that token. I can copy this token from this, and either I don't want to get copy because it is already showing here my number of tokens 6. I can go for here and my token. Okay, wait. Okay, here. So we have created DHT11. So you can select it DHT11 and it is already showing that token here. And once you create this code again, same as simple. If you create this code, it is showing that token in the code. Okay, it may be in a small letter, so it is maybe visible. So using Remote XY, you can again upload on cloud. Third is what especially ESP itself providing their terminals. ESP cloud. ESP is again showing their cloud platform for interfacing. Even Arduino has a cloud platform. So you can use Arduino IoT Cloud. So there are number of platforms you can use for it. See, Arduino IoT Cloud. So once you log in it, you can upload your values. So there are same routines. We need to create account, create a project, and we have to construct API key, either token to upload our data on a cloud. So these are the hobby-based, either less professional. We cannot call it industrial-based. But if you want to do some industrial kind of IoT product and cloud-based product, so we have to shift towards AWS services and Azure kind of services, Google Cloud kind of services, because those are professional. They are giving some edge code. We have to plant it in our microcontroller so they can easily, smoothly upload your data from the ground to the server terminals. So those are quite complex, and we have to learn everything of AWS with their green grass code and how we can construct edge kind of device. So there is quite a big scenario. But for the hobby base or creating a simple IoT product, we can use this less professional kind of device like Remote XY and ThinkSpeak and Arduino Cloud. We can use it. Okay, sir.
Yes, sir. Yes, sir. Thank you very much, sir.
Okay. Any other?
Participants, any questions? Sir, last question I have.
Okay.
I'm yes. I like to know about LoRa that we have seen.
Okay.
ESP LoRa.
Okay. ESP LoRa is a long range connecting module. That means it is what the long distance communication module. We are using ESP8266 for the Wi-Fi connection. It is in a limited range. A limited range, that means it's based on a BLE basis, like 5 to 6 meter, 10 meter, 15 meter. It has a maximum range. But
Uh-huh.
if we have to go for the rural kind of applications where the network is not available, so that scene we can use LoRa because it has a long range communication. In the rural area, it goes for 12 kilometers, maximum 12 kilometers of range. So if you have device connected with the IoT with without network or the long distance network, we can say, so we can use LoRa kind of device for the wireless communication. So if we go for the wireless communication, smallest device we called it Bluetooth, and second we called it Wi-Fi. Third is BLE, now advanced device. Then third is we have Zigbee, which provides more range as compared to ESP8266 and rather small wireless devices. And like ASK module, which is providing again 20 or 20, 30 whips wireless connectivity. Zigbee is more industrial and it is providing up to 100 meters, 300 meters, 500 meters connectivity. It is depend on the constructional field. Open field, it shows more longer distance, but in the construction field, it reduces the length of the communication. And after Zigbee, now LoRa comes into picture. LoRa has the low power communication, low range. There are frequency changes you can do with, and you can transmit your signal up to the 12 kilometers. So it's good for the interfacing where you are using rural applications. Maybe in a industry kind of approach, we can use Zigbee.
Yes, sir. So how much there is a cost difference between both simple ESP8266
Uh,
and
uh,
ESP LoRa?
Okay. If we go for the cost, Bluetooth module HC0 comes with a 3 to 400 rupees, and ESP like simple module what we are using ESP826601. There are number of modules in a ESP, but basic module we are using it is comes with the 200 rupees first. And if we are using Zigbee, which is professional, that comes with a single device comes with the 1200 and 300 rupees, but we need two Zigbees. So combinationally, we have to go for 4,000 rupees. Same for LoRa, we have to use two modules, trans receiver modules. So for the LoRa, again, there are some various ranges from long range to short range, but it starts with 500 to 1,000, 3,000, 4,000 rupees of LoRa cost. So it depends on your device, what kind of application you have. If I want to make weather forecasting for the rural area, I have to go for the LoRa because maybe there are not networks availability. So I have to go for the long range communication. And same for if I'm using for my company. So company has limited premises. Maybe it is constructed. That time I can use Zigbee. If I want to use in my home, I can use Bluetooth at ESP8266. So depending on the distance communication, you can select your particular wireless module.
Yes, sir. Thank you very much, sir, for your detailed insights. We have really, I think, mostly this is the first time that we have come into picture with all such technical aspects regarding Arduino and IoT. Thank you very much,
Okay,
sir.
sir. Okay, sir. Okay.
Yes. Ma'am, participants, please ask questions if any. Otherwise, ma'am, please
Yes, sir.
take the charge. Yes.
Okay. Thank you so much, sir, for your wonderful session. Actually, really, this is a hands-on session, and I'm sure after this session, all participants can do Arduino programming, and they would be able to upload the data using ThinkSpeak. Thank you so much, sir.
Okay,
Uh,
sir.
Thank you, sir. Participant will resume at 12:45 our next session for 12th one. Thank you all.
Thank you, sir. Yes.